Solving inequalities and absolute values. So today we'll be looking at our sheet. So before we get started on the sheet, let's go ahead and do some definitions. In inequalities, we'll use these symbols. And they come in pairs. When we graph things, here's 0, -1, -2, 1, 2. If it's an open circle, what does that mean? The number is not included in the answer. So if it's an open circle, that means we get infinitely close to it, but we can't touch that number, and that's our answer. So this number here is everything to less than, that's smaller than 2. If it's a solid circle, the number is included in the answer. Parentheses. The numbers next to the parentheses are not included in the answer. So if it's a parenthesis, remember, it's going to have two numbers. You're going to have a number here and a number here. So if the number has a parenthesis next to it, that means that number cannot be used in the answer. It goes infinitely close to it, but it's not used. Brackets, the numbers next to it. To the brackets are included in the answer. Now, these could be mixed up. You can have something like this. You can have something like this, or just straight up parentheses. That means what this number is not included, this number is included. Is not. These inequality symbols. The number is not included. The number that's referenced by the inequality symbol is not included. What is this symbol read as? And this symbol is greater than. It's very important because we read left to right. And we always, what we're looking for is, we know that 3 is less than 5. True. And we know that 9 is greater than 2. But we'll be talking about a whole series of answers. All x's that are less than 3. And this one here is all x's that are less than 2. In other words, I can go all the way up to, but I cannot use 2. That's where these come in. These equality symbols means these numbers are included in the answer. So that's very important on this distinction of these symbols. And we're going to use all of these on this sheet. Okay, let's start. The first sheet. These are called infinite and closed intervals. Let's first look at this picture. I start at the number A, and I'm going this way. You notice I shade that part of this, and I put an arrow, tells me where those numbers are going. The horizontal axis deals with which letter? X. So what we're saying here is this, and remember, we left to right. What we're shading here, these are all of my x's. So we read x, since it's to the right of something, that means it's greater than. Is it equal to? It's solid, so it equals to A. That's how you read that one. So x is greater than or equal to A. This is what it looks like graphically. We call that set notation. Because these are the sets of numbers we can use. Any number x that's greater than or equal to whatever A is. The next we call interval notation. What interval is our answer in? The beautiful thing about this one is, again, reading left to right, always start with the smallest one, with the farthest to the left is A, comma, and where does it go to? It goes to infinity. Infinity is always a parenthesis because you can never get to it. Now, A, can we use A? So since we can use A, we use a bracket. And so this is the pictorial representation. Let's look at the next one. From A, we're going to the left. Again, these are my x's. My x's are everything I can use. Those are my answers. So my x's, since they're to the left of A, that means it's less than solid, so it's equal to the letter of the number A. Let's look at interval notation. What's on this graph? What's the smallest number we get to? Negative infinity, comma, all the way up to A. Remember, infinity is always parenthesis, and A is solid, so it's a bracket. Good one. Do you have one of these sheets? Oh, again Wednesday. Oh, you can have the sheet when finished because yeah, I cleaned my bag out. Oops, sorry. All right, so the third one. Let's look at this picture. So we're going from A, we're going to go to the right. Remember, these are all my X's. So again, I state my X is what? Since it's to the right, my X is greater than A. Can it equal A? No, since it's an open circle. And that's my set notation. I use all the X's that are greater than A. Another way you can look at those, which is one of the reasons why people like having X on the left-hand side, is because since X is on the left-hand side, the arrow is pointing the direction it's shading. Since X is going that way, it's shading to the right. X is this way, it's shading to the left. That's one. Remember though, you don't always have to have it because X is greater than 2 is the same thing as 2 is less than X. So they mean the same thing. But it's a lot easier if you put X on the left-hand side. And the interval notation, read left to right. The farthest left in our answer is A, and it goes all the way to positive infinity. Infinity is always a parenthesis. Is A parenthesis or a bracket? It's a parenthesis because I can't use it. It's an open circle. And that's what I put up here. Open circles match with parentheses. Closed circles match with brackets. Open. And this one here. These are my X's. So I start with X. The arrow is going to the left. And there's A. X is less than A. So what's the smallest number? Going left to right, I start off at negative infinity and go all the way to A. You can never get to infinity, so it's always parenthesis. I can't use A, so it's parenthesis. It's open, right? So those are the first four. Those are called infinite and open, which means one of my endpoints is infinity. The next four deal with finite numbers. We have a beginning and an end. So here's the first one. Those are my X's. Since I have a beginning and an end, I start at A, I go to X, and I go to B. And it's always to the left. Because X is greater than A, but X is less than B. How would you do the interval notation? Look at interval notation only has these two symbols. Yes, they're equal, right? Oh, yes, I'm sorry. Yes, they are. That's what you meant. Yes. Yeah. Because they're included, we have to make them equal to. Thank you. So the interval notation. Remember, you only have a beginning and an end. Look at your picture. It's beginning at A, ends at B. Can we use A? Yeah, because it's a solid dot. So that's a bracket. Can we use B? Yes, it's a solid dot, so it's a bracket. And the next one, X is between A and B. So I have A, X, and B. And so is A included? Yes, so it's equals. Is B included? No, so it's strict inequality. A and B are my endpoints. So these are my endpoints, A and B. Is A going to be a bracket or a parenthesis? Bracket. Because it's a solid, or if you look at this one, because there's a line here, you put a line there, which means it's a bracket. Can we use B? No, it's open. So we have A, X, and B. In other words, X is between A and B. That's what it's telling us. And we can't use A, but we can use B. A and B are my endpoints. So it's A, comma, B, parenthesis, bracket. Parenthesis because it's a circle, bracket because it's closed. Again, X is between my A and B. And I can't use either of them. So they're both going to be parentheses. So that ends the finite portion, meaning we have a solid beginning and a solid end. So far so good. Now the next four deal with infinites, which means whenever we have infinite means we go to infinity. You notice how these go together towards each other? The next set, they're going away from each other. So these are my x's, which changes the way we have to write these things. We have one set of answers here, and we have another set of answers here. So this first one, x is less than or equal to a, there's a solid dot, or x is greater than or equal to b. Why is it or? Can you pick a number that's in both of these groups? So it can't be here and it cannot be here at the same time. So it's either going to be in one or the other. That's why it's an or statement. The interval notation will have two sets also. Remember, for the interval, for this first set, we go from negative infinity all the way to a. Is a bracket or parenthesis? Because it has a line. It's a solid dot. It's a bracket. And the second set starts at b and goes to infinity. And b is also a bracket. Now, for interval notation, we can't use the word or. We use the symbol for or, the union symbol. That symbol you read is this interval or this interval. Remember, these are my x's. So the first one, my x is less than or equal to a, because it's equal to because it's solid, or x is going to be greater than b. It's greater than no line because it's an open circle. Now, looking at the intervals, we have two set of intervals. We have this interval, which goes from negative infinity to a, and the second set of the interval goes from b to positive infinity. We have two intervals. Infinities are always parentheses. Solid is a bracket, open, and a union goes in the middle. My x's. So the first one, x is strictly less than a, or x is greater than b. Remember, I told you, look where the arrow is shaded. Since this side here is going to the left, it's going to the left. This side's here going to the right, it's to the right. So the endpoints are negative infinity to a. A is open, so it's parenthesis. Union from b to infinity. B is solid, so it's a block. So x is less than a. You can't use it. Or x is greater than b. And you cannot use that. This first side goes from negative infinity to a. And you can't use infinity and you can't use a. Union with b to infinity. You can't use b and you can't get to infinity. Those are the first three sets, the first 12. Now comes the three interesting ones. How would you define a point? X equals A, exactly. How would you use it? Interval notation. What's the lowest you can go? What's the highest you can go? So it's just A, and you can use it, so it's bracket. What if you don't want A? Everything else but A. In other words, I want all of these or all of these, but not that one. How'd you do that? Take a guess. Anybody? Anybody? Ferris Bueller. So we say that X is less than A or X is greater than A. That simply says that X is not equal to A, which is what X not equal to A is all about. That's a shortcut. And how would you use it? Interval notation. In parentheses, yeah. Not A. We don't want that one. And the last one, these are all my X's. So how would you do the set notation? Actually, no, that would go here. I'm sorry. Here, just put X. You could also say that X is equal to all real numbers. And there's empty blank one on online where this whole thing is explained again. Yeah, but those are all the inequality symbols we use. The problem is getting there. And once we get there, what do we do with it? Let's look at some examples. Put this answer in the other two formats. We can take a picture of it if we can. So what format is this in? Yeah, since it has pointy things, it's set notation. So we have to put it in interval and graphing. So put it in the other two intervals. Now, whenever you do conversions, this is my favorite way of doing it. Always go to graphing first. Convert whatever method you have, go to graphing first. If you're given in graphing, that's easy because then we do what we've just been doing. So is this an open or closed circle on 3? It's a less than. Oh. It's open. You said closed. What direction is the arrow pointing? Left. Yeah, because as long as the X is on the left-hand side, we know it goes the arrow that's pointing. So it's going this way. To what number? Which gives us our set notation. Our set notations, we go from the smallest number to the largest number. So it's negative infinity to 3. Parenthesis on infinity or bracket? Always parenthesis. You can never go to infinity. That's why it's always parenthesis. Now, open circles, is that parenthesis or bracket? Parenthesis. Okay, give me the other two formats. So the graph would go from -4, open or closed on -4. Closed, because it's a bracket. Which direction? Left to -infinity. And the other side starts at 4, open or closed. And it goes to infinity. So these are x's. So how would you define this side? Very good. Or 4. Perfect. That's it.
Oh,
X is less than -4, or x is greater than 4.
the first.
I'm
Oh,
that's it. Absolutely. Good catch. Good catch. Good catch. Okay, I'll give you now. Here's a graph I'm going to give you. There's the graph. Give me the other two formats. Let's start with the far left. What notation is this called? Set notation. So how would you write this in set notation? Very good. You can put those in parentheses if you want to. Make them easier to read. Very good, yeah. Because x is between -4 and 3. Equal to, not equal to, equal to, equal to. So this one's going to be, you have the endpoints right here. Will be -4, 3. Are they brackets or parentheses? Yeah, bracket in the first one, parentheses in the second. Symbol, union, 5, 7, and they're both brackets. All right, how would we do the set notation? So first part, x is strictly less than -10, or very good, or very good, very good, very good. Just treat each one of them, and then for each one separately, put the word or between them. In this one here, you didn't have to put, since it's a constant number, you can just put 15. Yeah, because we know these are all factors of x. You just put 15. That could have been the value you use. Or 15, yeah. Now, intervals. So this first one, this first interval, it goes from -infinity to -10. Is 10 a bracket or parenthesis? Parenthesis. Let's open. What symbol? Now here, I go from -5 to -1. It's a bracket because it's included, parenthesis. Or start at 2, go to comma 10. They're both parentheses. Or 15. Or start at 20 and go to positive. They're both parentheses. So it doesn't matter how many you have. It's just this, the format's still the same. So that's inequalities. Now we can do algebra on inequalities. There are two types of solutions we get here. One we could do on a linear equation that would just only comparing x. Or if we have two variables, then we have to have x and y, which we have regions. We'll do that later in this course. That gets more complicated. All right, so let's solve inequalities. Solve inequalities. The rule, treat as an equal sign. Here's an easy one. X plus 5 is less than 2. How would you solve that if it was x plus 5 equals 2? How? Subtract, this is a plus, we'd subtract 5 cosines. So now x is equal to -3. X is less than -3. So the graph would look like -3, open. The interval would be -infinity to -3. There. You have to be able to convert from any one of the three methods to the other two. Is everybody okay with that? Because I'm going to start giving more complex equations here. X minus 8 is less than or equal to 1. Finished? I want it in the other two formats as well. I want it in graphing. What format is this in already? It's set notation because we have inequalities. I want it in interval notation and graphing. What's the first thing you do? Add 8 to both sides because we're trying to get X by itself. Then divide by 3 to get the X by itself. So there's 1. That's set notation. What's the graphing gonna look like? What number am I dealing with? Positive 3. Is it an open or closed circle? Closed circle. Which direction does it point? To the left. And it goes all the way to negative infinity, which tells us our values for the integral notation. Since that's solid, there's the answers. Let's do some more. All right, put this one in solve this one and put it in the other two formats. What's the first thing I do? Yeah, get rid of the 4. So 10 is greater than 5x. Then divide by 5, get the x by itself. So 2 is greater than x. Now, you can solve it this way if you want to, but how would you graph it? Yeah, so you have a 2 there. Is open or closed? You guys are saying the same answer. There's a shade to the right or to the left? Remember, if the x is on the right hand side, it's the opposite. So if we flip this one over, if we flipped it, it's got to point to the x. Remember, if x is on the left hand side, it's just what it is. But if x is to the right, it's the opposite side. It goes the opposite direction. Ooh, trick question. Because this thing says that 2 is greater than x, which means that x is less than 2. So that's what whenever you get to these things, always put it so x is to the left hand side. Just take it pretty much and flip your paper over. That's all you're really doing. Because if you did that, you'd have this. So put your two numbers, x and 2, and it's got to point to the x. So our answer is negative infinity, comma 2. They're both parentheses. Remember, I said treat this the same way you do equal signs. The rule is this. If you have fractions and an equal sign, get rid of the fraction. Get rid of the fraction. That's the rule. If you have fractions and an equal sign, get rid of the fractions. This is how we do it. Find the LCD. What's our LCD for this case? It's the only D. Yeah, the only number we have is 5. So find the LCD, then multiply each term by the LCD. How many terms do we have here? Three terms. This is one term, so it's a fraction. This is a term, and that's a term. Anything separated by a plus, minus, or equals is a term. So in front of these parentheses, I put a 5. There, multiply each term by the LCD. Third step is reduce, cancel. Because what this is going to do is get rid of the fractions. So this 5 goes in the fat 5 one time, so it's gone. Nothing else. So what we have right now is this. That looks a lot easier. Now we multiply to remove the parentheses. So 5 times 3 is 15. Negative 5 times positive 1 is negative 5. And solve for x. And here's another set of rules we haven't talked about. Whenever you have x's on both sides, which one do you move? No. No. That's not a right answer. To solve for here, always move the smaller x to the larger x. Why would you want to do that? Why do you move the smaller x to the larger x? What's that? But why? Yes, you're right. It is easier. Very good. Exactly. It's always going to be positive. Your coefficient in front of your x will always be positive. Because if we move the 15 over here, we have to subtract 15, right? So then we'll have a negative 11x. Negatives cause problems. So if we move the smaller to the larger, 15 minus 4 is 11x. We'll always have a positive in front of our x. So move everything that's not x to the other side. So we add 5 to both sides. We have 8 is less than equal to 11x. Next step, divide both sides by 11. That gives us 8 over 11 is less than equal to x. X is on the right-hand side. So how do we flip it? When we flip it, we get what? X. It's pointing to the answer, so it's pointing away from x. The answer, the arrows have to point to where it's pointing. Now we can graph it. So what this would tell us is we have 8 over 11. It's a solid dot. And it goes to the right. So 8 over 11, comma infinity. That's right. So always move the smaller x to the larger x and then work from there. So let's look at another example here. Make it a plus. Make it a plus 5. Yeah. All right. Same as the order of operations. What do we do first? We could distribute. Let's look at both ways. Let's say we distribute first. As long as you follow the rules of math, you can't go wrong. So if we distribute first, 3 times 4 is 12. 3 times 2 is 6. Then what do? Combine like terms. Yes. Whenever you get rid of parentheses, always combine like terms. 12 plus 5 is 17. Ooh, 16. Then what? Yes, subtract 17. Yes, yes. So 17 is bigger, it's negative. 17 minus 2 is 15. What have I told you since day one? Do you always divide by negatives? No. What do you do first? Change everything across the board. So this one becomes a positive. This becomes a what? Flips. Everything changes. And that's what my rule of change everything first before you divide. It makes it much easier. Everything changes. And then now you could divide by 6. So what does 15 over 6 become? Do they have anything in common? What is 15 made up of? 3 times 5. What is 6 made up of? 3 times 2. So they both have a 3 in common. So it is 5 over 2. Which makes it, I flip it over, it's got a point to the x. So since it's equal to, it's a solid dot, and it goes to the left. So the interval notation, is that what you had? Oh, no. No. As I said, whenever you have a negative in front of your x in the last step, change across the board, change everything. That's, so there's nothing to memorize. I changed this one to positive. I changed that from less than to greater than. And I changed that from negative to positive. Everything's taken care of for you already. Now, that's if we distributed first. Did we have to distribute first? No. Let's see. What could have we done first? Subtract 5. We could have got rid of what we don't need first. So we have negative 3. 4 minus 2x. Those cancel. Now what do we get rid of? We don't need a 3, so we divide by it. Negative 3 divided by 3 is negative 1. Then we get rid of the 4. Negative 4. So that makes it negative 5 is less than equal to negative 2x. Change the signs, change everything. So we have 5 is less or is greater than equal to 2x divided by 2. So x is less than 5 times. But there's also another thing we could have done that could have saved us not not have to remember any rules. So what if we had this? What if we had that? The typical rule says, what do we move first? Get rid of the 5. But since we're dealing with inequalities and x has a negative, we could move the x first. Change it to a positive. That takes care of flipping the inequalities for us. Now we have a positive x. We don't have to worry about any flipping of signs. Subtract 3 from both sides. And divide by 2. So if you, along the way, if you see your x has a negative in front of it, move the x. That'll save you a bunch of time. So far, so good? Tripartite. What does tri mean? That? Here's an example of a tripartite equation. You have 3 parts. This actually has 2 equations at one time. We have this equation and we have this equation. They just happen at the same time. So to solve these, only worry about where the x is. Your objective is to get x by itself. Whatever you do here, you do to the outer 2. So what do you have to do in the middle to get x by itself? Divide by 3. So I divide everybody by 3. And there's your answer. Which would give us negative 4/3, comma 5/3, and the interval notation. So far, so good. So again, we can have equations on the inside, and that's what we're going to do now. I'm going to give you a tough one in the middle, so we have a lot of moving things. There, let's look at that. Remember, your center, wherever your x is, that is your guide. What would you have to do first to get x by itself? What do you have to get rid of? Get rid of the 2. How do you get rid of the 2? Yeah, that's the LCD. Multiply each term by the LCD. So that gives us 14 is less than, the 2's cancel. 2 minus 3x. 2 times 10 is 20. That's the first step. Second step, you have to get rid of the 2 here. Subtract 2 from everybody. Fourteen minus 2 is 12. Those cancel. 20 minus 2 is 18. What do we notice? There's a negative in front of the x. So we got to change everything. All the signs and all the inequalities. So it becomes negative 12. This flips, positive 3x. This flips, negative 18. And then divide by 3. 12 divided by 3 is 4. X. Negative 18 divided by 3 is 6. But this is backwards because its arrows are pointing in the wrong direction. So we got to flip the whole thing around. We put the negative 6 there, put the x in the middle, and the negative 4 there. So this inequality has to be pointing towards the negative 6. This inequality has to be pointing towards the x. So there's my answer. Unfortunately, we don't have enough time to finish up the absolute values. We'll do that next time. Because we have to solve those as well. And those actually are formula driven. And yeah, so it's a little bit more difficult than this. Okay, everybody, have a great, safe day. And I will